Okay, let's go ahead and get started. Can you hear me okay in the back here? Okay, awesome. So my name's Sandy, and I'm here to talk about the Rounding Up the EMUs app for Android. So thanks for coming. Welcome to the talk. Today we'll be talking about what's an EMU and why is it in this app. I'll be giving you a short demo and then talking through some of the data and design steps we went through in building this app, as well as covering some app development patterns. On the right here, you'll see a nice diagram kind of showing how we characterize ArcGIS development. And we often use this ourselves, of course, internally when building apps. And it really refers to preparing the data for the map and provisioning the map in ArcGIS Pro, and then designing the map and fine-tuning it and producing a web map, and then finally consuming it in an app. And so we'll touch on some of this during the talk. Before I can get started about talking about EMUs, I need to kind of give you some background on oceans. So oceans provide us with 97% of our water. They occupy 70% of the Earth's surface. And they drive climate, weather, and are tightly connected to life on the planet. Yet, despite all this, only 5% of the ocean has been explored. And with increasing resource utilization and demand on oceans, including overfishing and pollution, it's becoming more and more important for us to get a good understanding of what lies in the ocean and develop really good maps so that we can start to really think about conserving and managing this valuable ecosystem. So as a result, the group on Earth observations commissioned a global map of ecological marine units. Ecological marine units are regions in the oceans sharing similar salinity, temperature, oxygen, and nutrient levels. The EMU project was created through a partnership led by Esri and the USGS in collaboration with several other organizations. The EMUs are based on NOAA's World Ocean data, collected over a 50-year period. These 52 million data points were used to construct a 3D point mesh in ArcGIS Pro. Once this mesh was created, the research team applied statistical clustering to group together areas with similar properties in 37 distinct physically and chemically distinct EMUs. So with that, I'm going to switch to a quick demo. And as you saw in the plenary, this is a web map showing ocean regions that share this, with each different color being represented by a different EMU. And we can, of course, start to explore what those EMUs look like as you go below the surface by tapping on this slider button. And what's happening here is a feature layer that's being used is we're setting the definition query as we toggle the slider. You can also search for ocean features. And here we can search for the Mariana Trench, which is a pretty well-known ocean feature. And we zoom right to it, you can kind of see the trench here. It's often the deepest part of the ocean is found in the Challenger Deep section of this trench. But we'll just kind of tap on one of the locations, and we see that that's about 7,000 meters. So the summary is shown here, and this represents the water column from the surface of the ocean to the bottom. And each of these different colors represent a different EMU in that water column. And as we toggle up and down that water column, we see different details displayed about the contents of that layer. So for example, this bottom layer is very cold and very hypoxic. As far as nutrients go, it's got a high nitrate and medium phosphate, but high silicate. And it's about 5,000 meters thick at this location. So again, this is a particular point in the ocean, and this represents one point as a water column. And we can drill down and see more details here about that specific water column and for this particular EMU level or layer. So for EMU 13 at this particular location, we're seeing different properties. In this case, the black lines in the graphs represent the ocean high and low values for temperature, salinity, oxygen, nitrate, phosphate, and silicate. And then the blue regions in the graphs are the EMU high and low and then the EMU mean is represented by the pink dot. This graph was generated using MP Android Chart, which is a free library available on GitHub. Navigating back to the summary page, we can also look at how these properties change with ocean depth. So now we just look at one property, temperature in this case, and see how at the very top of the layer, temperature is pretty nice and warm, and then quickly decreases as we get down to about 2,000 meters below the surface. And we can see the same type of chart for various other components like salinity, oxygen, phosphate, silicate, and nitrate. So that's a quick demo of the app. Let's return now to the slides. So one of the things that we went through to build this app was to prepare the data for that traversing the depths that you saw at the beginning, where we tap on the slider and move up and down the ocean depths. This was a kind of a difficult problem to solve because we were trying to show all of the data, but in a way that was kind of didn't interfere with user experience and still maintain data integrity. The app currently wasn't really able to display all 52 million points at one time. So what we did is we used a geoprocessing workflow to automate or to generate polygons, and we did this with the ArcPy geoprocessing package using a Python script. So this summarizes the steps we went through to generate these polygons. We took the points and converted them to raster, and then from those rasters we created polygons, and then we dissolved those polygons using geoprocessing tools. And we then imported those polygons into ArcGIS Pro, symbolized them, and added some transparency to make the map look good. And then we published it as a web map and consumed it in Android. So let's take a look at the code, some of the Python code that we used for this. Let's see. Just going to... So I'm looking at this code in Android Studio, and we're going to kind of start with the main part of the script. I'm not a Python expert, but I know enough to point us in the right direction here. So we're setting up arguments for the command line, and we're setting up the environment for ArcPy to point to the geodatabase and where to put the output. And then we're defining some feature classes. And then we actually call this main function called process EMUs by level. We can go take a look what that looks like. So this basically prepares the script and starts to set up all the iterations through the depth levels. So there's about 100 depth levels in this data set. And as we iterate through the levels, we're selecting points as a new selection in each level. And then we're calling the generate EMUs function, which essentially groups those points together and creates a new raster to polygon entity. And then we dissolve the polygons and add data to the schema, which we're using in the geodatabase. And we do that for each level. So that way we're, again, walking through each level, creating rasters from the points, and then creating polygons from those rasters, and then updating the database, the geodatabase that we'll be using in the app. So that's a quick summary of how we got that data pre-processed and optimized in ArcGIS Pro and using ArcPy. A second topic to talk about is the app development patterns that we used in this app. We have been using the model view presenter pattern, which is common to many of us. But as a review, I can just talk about it briefly here. The reason we want to use model view presenter is because it separates areas of concern in the app, and it makes it easier to test, easier to understand, and easier to change. So essentially what we have here is a very passive view that's separate from any logic. The presenter houses the logic that's used to basically implement business logic and retrieve data from the repositories or services and format that data in such a way that it makes sense to the view. And the view really is just a dumb view here. The model refers to objects that represent interesting things to the user. So in this case, it's a water column, or maybe it's a point or location. So the presenter really is the kind of master controller here, and the view is very passive. And we've also structured the app in such a way to reflect this. So looking at the app structure here, we see the data directory, and then we see the map directory, and each, in terms of the data is really kind of acting as the repo, and the map is one of the kind of functions in the app, and we have a contract, which is an interface for the view. We have the view as the map fragment, and we have the controller or presenter as the map presenter. And so we've done that consistently throughout the app to help discriminate behaviors and functionalities. Now to dig into a little more detail here, how is this implemented in the app? Here we have a sequence diagram showing what happens when a user starts the app. So the main activity receives a notification to start up and immediately starts by creating a new instance of the data manager. Then the app, the main activity, creates a new instance of the map fragment, and then map fragment then is used to create a new map presenter. Once the map presenter is created, the fragment or the view calls the start method on that presenter, which then calls back to the view to start up the map. So let's take a look at what this code looks like. Let me just get you over there. So back to Android Studio, and here we're, let's see, where's my mouse? So in the main activity here, towards the bottom of the onCreate function. So the onCreate function is right here at the top. We've done some setup with the the floating action button. We've shown the progress dialog as needed. And here is where we start to make a new singleton of the data manager, which is used throughout the app. And then we're setting up the map fragment. So navigating to the setup map fragment part, we're setting up the toolbar, and here's where we start to create the map fragment. And it's once we have the fragment created, we can pass in the fragment and the data manager, which are both used by the presenter. And now the presenter is ready to receive notifications. At this point, the map fragment can be called, or the map fragment calls, this is the map presenter, and we're setting the presenter for this view. And once the fragment completes its create view function, it's ready to start interacting with the presenter, so it calls the presenter start. So this is in the map fragment, and we're in the onCreate view at the very bottom of that function. So the view has been set up, presenter can now be engaged, and we start that presenter. Starting the presenter does several things. So first of all, we show a progress bar while the map is loading, and we create the map here, and we create a map with the oceans zoomed out at a particular zoom level. And then we're layering on top of that map a tiled layer from the open services that are available for this project. So this is showing you that those colored polygons at the surface of the ocean. And once the map is set up, or sorry, this is still in the presenter. The presenter is basically provisioning the map to be used in the map view. So we tell the map, okay, I'm ready to set up the map, here's your map. And then we're also adding the layer to the map, again from the presenter. So the map really is acting, the view here, the fragment, is really acting as a dumb view. It's just consuming things that the presenter is giving to it. So we're setting the map view and setting the map to the map, setting the map to the map view, and then we're setting up some listeners to listen for touches and draw changes. One thing I wanted to point out about these steps is to help you understand kind of what we're doing in the web map itself. So as you saw, we start with an ocean base map layer. That's the first call when we instantiate the ArcGIS map. We create it with a base map of the ocean. And then we're adding this tiled feature layer on it right away, which shows you the colored polygons. And note that, I don't know if you can see it so well in here, but when you're zoomed in, those shaded regions end up looking like small dots. So the tiled layer has a different look and feel at higher, when it's zoomed out versus when it's zoomed in. And that's of course something you can configure in ArcGIS Pro. So the feature layer at the very top, I didn't show adding that here because this is really only engaged, the visibility of that top layer is only engaged when the slider moves. So you can see how these two pictures show different EMU patterns at different depths, and we only show those when you move the slider, otherwise it's invisible. Okay. So the next step is to walk you through a similar sequence diagram, now kind of explaining what happens when you tap the map using the MVP model. So tapping the map the tap event is captured by the map fragment. And the map fragment calls to the presenter and says, basically, calling the set selected point. Let's see if I can set selected point. The map presenter in turn is going to query for that point with using the data manager. The data manager, again, is responsible for communicating with the repository, in this case, the service. So here we have the query feature, async query is being called from the data manager, a singleton, against the service feature table. And then when the service feature table service, essentially the service that's being hosted, is returning a feature query result, and then a new instance. So from that, in this case, I'm querying with a point, but I'm getting back data that I want to display. So I'm actually querying for non-spatial data, which is that summary view that you've seen of the water column and all the different statistics. The new instance, or a new instance of the water column is created. So the water column here is the part of the model, and this encapsulates all the things we care about in a water column, like how many layers there are, what are the different layers in that column, and what are the different statistics for each layer. So once I create that water column, it's returned to the data manager. It's returned to the data manager, which then returns it to the caller, the presenter. And the presenter passes it back to the view, and the view then displays that water column. So this is a kind of just a quick walkthrough, and we can take a look at how this works in code. And we start with T1. So as I mentioned, this is on the fragment, and there's a method basically that's part of the touch listener that we've defined as on single tap confirmed, and this is something you can extend from our existing map touch listener. And what we're doing is we're using the point that was tapped on to basically reverse engineer what geolocation was selected. And then here's the call to the presenter, passing in the selected point. Then navigating to the presenter, we see how the presenter is basically telling, okay, show a progress bar, telling the user that we're fetching detail. And we also want to show the click location. In addition, I'm going to call the manager to query for the location that I've been given. And here I'm using an interface, a callback function to, that the data manager will call when this query completes. So let's see where the data manager handles this. So the data manager's function query for EMU at location is passed an envelope and a callback. And then it processes, it sets up a future, a query, and then delegates the processing of that query to process query for EMU at location. And process query for EMU at location is a loadable pattern. We're going to be adding a done listener to this. So when the function completes, we have some additional logic that's executed, including extracting the observations that are coming back as JSON, and then creating a water column based on that data. So there's a bunch of gymnastics we're doing here to kind of wrangle the data back into a form that we care about. And then we're passing back the water column right here. And this goes back to the presenter. And the presenter basically turns around, gets that water column, tells the map, okay, hide your progress bar, I've got some data for you. Or if I don't, show an error message or no EMU found message. If I do have data, set the selected point that I clicked on, set the viewpoint, show the clicked location in the map view, and then show the summary using this water column. And the show column method is basically showing the bottom sheet, because that's that bottom sheet that comes halfway up, and we're setting the visibility to visible and toggling some behavior based on the current state. Oops, I skipped a step. This show summary is being called from the fragment, which calls back to the activity, and that's what I just showed you here. This is the main activity, which has a show bottom sheet, and this is where then the data gets displayed. So that's kind of a hopefully not too long-winded explanation of how we're using MVP in this app. And if you're interested in more, you can certainly download the app, ask us questions, get it on Google Play. But we found that the MVP pattern has been really useful to help us kind of manage this app and grow it in a way that's manageable and easy to understand. Let's see. So here are some resources and links for you to use. There's actually a web app version of this app that does most of this functionality. And it was built first as part of this project, part of the EMU project. You can find more information about EMUs themselves on Esri's website. And of course, as I mentioned, all the source code and documentation is open source. And please, we invite you to collaborate with us on GitHub or get the app on Google Play. And there's even a movie about the EMU app and what EMUs are. So wanted to thank all the folks who made this project possible, including Keith, Sean, Don, Dan, Justin, Mara, Mike, Will, and Nitin. These are all folks that work behind the scenes to help build maps, help generate services, help provide feedback, and help publish. And I'd urge you to take our survey and let us know how we did. With that, I'll take some questions if there are any. Yeah.
Yeah, I was just wondering with the MVP pattern, there was on the map fragment, for example, you have the map and then the slide up bottom view. So did you separate that out so that each of those components kind of had its own model and presenter, or was that all kind of in one big fragment?
Yeah, so the bottom sheet, I got this. So the bottom sheet was really controlled from the main activity, and it has its own logic because it's a widget that's essentially made by Google. It has its own logic, so I didn't separate that out into its own MVP. I really just had the map, the summary sheet, and the charts under this MVP model.
So each of the charts, for example, when you slid into a chart view, that had its own
MVP.
That had its own MVP stack, so to speak. Yeah. Okay.
Okay. Anyone else? Do you have a question? No? Okay. Thank you. All right. Thank you so much.